Hello and welcome to the second part of our mini-series about melting complex objects. In this episode we'll cover shading and rendering a scene in Karma. Now, while the first episode was an episode about lots of neat little tricks, this episode is mostly about compromises. The way meshed fluids work unfortunately makes it impossible to get all the details from our textures perfectly onto a fluid without any downsides. So our main job for today will be to choose which downsides we can live with and to choose a workflow accordingly. So what are these choices? The main one will be if we want to use UV coordinates and textures on a fluid or point colors and attributes. UVs will give us crisper details and a more straightforward shading workflow, but we will get artifacts around UV seams. Point colors, on the other hand, won't have that seam issue, but details will be mushier and the shading workflow will be a bit more tedious. Also, since we're rendering in Karma, there will be a choice in shader building. An easy to build shader that will only work with Karma's CPU and a more complex one that will also work in XPU. In this video I will show you the UV workflow and the easier Karma shader in detail, and then we're going to take a quick look at the changes needed for those other workflows. And of course you will find all variations in the scene file download. But now let's jump into Houdini and get going. So let's finish our melting setup. This is where we left off last time. This is the setup we built to blend from a high poly object right here to a mesh fluid right here. And now we want to work on bringing first of all our different materials and then also our UVs to a flip fluid down here so we can render this all as one object. And I first of all want to work on my different materials, and in the end in the shader I want to use some attributes as masks for blending between different materials. Now, taking a look at our high poly object up here and taking a look at the info panel, we have this name attribute, and this name attribute separates our three different materials. We have one for the preview surfaces right here and right here. We have one for the core in the middle, and we have one for the stand. And what I want to do is I want to take this name attribute and turn it into 3 point attributes that each will act as a mask for later blending between different shaders. To do so, I want to make some room here, and I'm simply going to use an attribute create node, and I want to create my first mask here. I want to set the group to work just on the core name attribute like this. I want to call my attribute mask underscore core. This should be a point attribute, this should be a float, and everything that's inside this group should have a value of 1, and everything that's outside of this group should have a value of 0, like this. And now if I create a visualizer for this, bring up the info panel and click on mask core, you can see just this. Everything that's the core of our object right here is red, which means this attribute has a value of 1, and everything else is blue, which means this attribute has a value of 0. Now we have 2 other objects that we need to do this for, so let me quickly speed through this. This will just be the same setup for the different groups that we built before. So this is our mask for the preview surface, which also grabs the preview surface up here. And this is our mask for the stand, which also grabs the stand group up here, like this. And on our geo spreadsheet or info panel, we should now have our mask core, our mask preview surface, and our mask stand. And they each should correspond to a different part of our object. Let's put a frame around this. We're done here. Now we have to transfer those mask attributes from our main geo or high poly object right here to a fluid right here. And we're going to do this alongside our UV coordinates. To do so, let's make some room down here. And I first of all want to branch out from this point right here, from a point deform. I want to branch out down here to a null. So I'll simply drop down a null, put this in as a reference. Let's maybe disable our visualizer, and I first of all want to work a little bit on the UVs of this object. I want to transfer those UVs later to points on our fluid. However, if I just drop down an attribute promote and promote my UVs from vertex level to point level, we should see right here that we have some issues around UV seams. We now have this band right here that wasn't there before. And we can fix this issue at least right now by simply dropping down a vertex split node right before. Let's change the attribute that we want to work on from N to UV like this. And now this attribute promote works fine. and it works fine because right now, or what this vertex split node does is it splits our geometry right here along this line, along this UV border, and this fixes our seam issue right here. Now we want to bring this over onto our fluid, so for this let's use an attribute transfer node. Fluid goes into the first input, and let's put it back into the merge down here. And on here, on point level, we want to bring in, first of all, our UVs, and then also all our mask attributes. And since all of them start with mask and an underscore, I can simply replace this core here with a star, and this should grab all our attributes. And taking a look at the info panel here, we now have a mask core, a mask preferred surface, a mask stand, and our UVs. And we can already also see those UVs in the viewport. Right now, these UVs look pretty crap in my opinion. We can make them look better by blurring them. So let's drop down attribute blur. On it, change the attribute that we're working on to UV. And the more we up our blur resolution right here, the finer or the crisper those edges right here get. But also, the more we up the blur, the stronger the artifacts around those UV seams get as well. Now, there are still some ways to hide those UV seams, but they all have their pros and cons. In this case, I'm just going to lean into this sort of fluid behavior around those UV seams, because this seems like something that would happen if you melt stuff, and I'm actually just going to really play into this effect by upping the blurring iterations to a value of 50, like this. And finally, since our UVs on this geostream up here on a high poly object, since I use UVs here on vertex level, I want to have them on vertex level on here as well. So let's finally drop down attribute promote and promote our UVs from point to vertex like this. We're done here. Let's add a box around all of this as well. Something like this, and maybe also get rid of this null. We don't need it for our setup. Make it look like this. And now finally we should take a look at our masks. Let's maybe take a look at the core mask like this. And let's maybe take a look at it when our object right here is completed. And right now we have this very sharp transition from our other objects or other shaders to our core. And I want to blur this as well, but I want to blur this in this attribute blur right here, since this blur works both on a high poly object and our flip fluid. So this will make the transition a bit nicer. So all I'm going to do in here is add to the attributes that I'm blurring right here all my mask attributes as well. And I think the star trick right here does not work, so we have to bring them in one by one, something like this. Now finally, before we jump to rendering, there's one additional step that I need to do, because taking a look at the info panel right here, we still have this name attribute right here, which I don't want to use later in shading. And this will force Karma, if I import this, or for Solaris to split my object into different objects based on this name attribute. And I don't want this. I want this as a single object. So in the end, as a last step, I'm simply going to delete that name attribute right here. These are the final attributes that we're going to bring into Karma in the end. And now it's time to jump into Karma. Let's make sure we have this render null right here at the end that we're going to reference in Solaris. And now let's jump to our Solaris desktop and let's bring in our geometry from before. Let's first of all use a sub-import node. Let's call it shader ball, and let's select our out render under a geo1 fluid object like this. Taking a look at the scene graph tree, we should also see that we have just one shader ball here with one mesh. And if we click on this mesh and take a look at its primars down here, we should see that we have our different masks, as well as a UV attribute, which in this case, because it is Solaris, is called ST instead of UV, and also a temperature and total burn primars. Now I'm going to build a bare minimum render setup. You can take a look at a more complete render setup in the scene file that you can download, but this will first of all consist of a material library. We're going to build our shader for our shader ball. Let's dive inside there. Let's create a Karma material builder like this. Call it shader ball as well. I want to tweak those settings on this object later, so for now let's jump back out and let's simply assign it. Let's autofill materials, let's check assign to geometry, and let's drag in our mesh 0 like this. Next I want to create a simple lighting setup, and I'm just going to use a dome light for this. And in here under the texture, I'm going to load in a texture from Max Ross, this bathroom texture right here. And this is a texture that I think you can download for free from Max's website. On the base properties, I upped the exposure of this light by 1, and under the transform, under the Y rotation, I rotated it by minus 85 degrees, like this. And then finally, we need a camera and some Karma render settings. So first of all, for our camera, let's find a view that we like and simply Control-click on our camera. Let's maybe go to the View tab of our camera and up the focal length to 80. I like those long focal length a bit more. And finally, let's drop down our Karma setup of final rendering like this. And as I said before, there are two different shaders that we can build. One sort of simple shader that only works with Karma CPU, and one a bit more annoying, a bit more complex shader that will also work with Karma GPU or Karma XPU. For now, I'm just going to show you how to build the simple version, and then we're going to look at the changes you need to make to build the complex version. So right now, I'm going to leave this at the CPU engine. We can save a scene, take a look at the rendered view. This should look quite fine, which it does. And now let's finally work on our material. So what I want to do in here first is I don't want to have one Material X standard surface in the setup. I want to have 3 Material X standard surfaces in the setup and use those mask attributes that I created earlier to blend between those. So first of all, let's move this one a bit over. Let's maybe also grab the displacement and the material properties and move those down. Make some room here. And I want to create 2 copies of this like this. And just to differentiate those 3 copies, let's maybe give the first one a green color, the second one a red color, and the third one a blue color. And now I want to use some Material X mix nodes to blend between those different shaders. So first of all, for a first mix or first node, and let's maybe call this core because this will be our core material. This goes into the background. Our next material, which will be our preview surface, this will go into the foreground. And then let's copy this one more time. The mix goes again into the background, and our last material, which will be the stand, this goes into the foreground, and this goes finally into the surface. And those 2 mix nodes are the reason we are using Karma CPU in here instead of Karma XPU, because Karma XPU currently only supports mixing 2 materials, 2 shaders, and not 3 shaders like we're doing here. Next, we need to bring in our masks to mix between those different surfaces. For this, I'm going to use a Material X geometry property value node. And this will first of all be for the first mix or mask underscore preview surface like this. Let's wire this up into the mix input and let's copy this. And the next one will be our mask stand. Let's try rendering this. Let's set a mode to Karma CPU and we can already see this mask working. Let's jump a bit forward, a bit backward in the timeline so we get to see all 3 objects, and indeed our masks in here are working. Now let's actually build our materials. For our core surface, I simply want a sort of glossy object, and as a base color I want to bring in our Entagma logo. So for this, let's drop down a Material X image. This goes into the base color like this. And its image that I'm going to load in is the Entagma N on white with 512 pixels. And for some reason, the UVs on this core surface aren't really centered. So to make our image here actually centered, let's drop down a Material X texture coordinates node and a multiply node. Wire this up like this. And we need to multiply by a value of 1.35 like this. Now our logo is nice and centered. Next is our preview surface. In this case, I just want to change the color. In this case, this will be a UV grid. So another Material X image. Let's load in this uvgrid.png. This goes into our base color there. And this is all I want to do in here. And lastly, our stand should be a metal. So in this case, let's change our color to a light gray, something like this. And let's up the metalness to 1. and I'm going to leave the roughness as default. Now these are all pretty simple materials, but with this setup you can pretty much build every shader you want. Just plug in other different textures into the different inputs of the standard surface, add normals, add bump maps and so on. This is pretty simple in this regard. But again, unfortunately, this shader only works with Karma CPU. Let me quickly bring in a shader that will work with Karma GPU, and let's take a look at this next. Oh, and of course, one thing that I forgot right here is we also need to add, of course, a glow to our object because we want to melt our object. So let's quickly build this as well in here. So jump back into our shader. And for this, I want to change on all three materials, both the emission and the emission color. And the way I'm going to do this is using our temperature attributes. So first of all, let's grab another material X geometry property value. Let's grab our temperature. And first of all, I want to work on the emission intensity. So for this, let's grab a multiply to change the strength. And I want to multiply by a constant like this. And the constant will have a value of 10. And then also I want to work on the color based on a temperature. For this, I'm going to use a black body node because this will give me the right color temperature based on a temperature attribute. And for this, I'm also going to use a multiply node. Temperature goes in here, goes into the black body. And again, I want to multiply with a constant. And in this case, the constant will be quite a bit higher. Let's make it 210 in this case. Now finally, let's expose the emission outputs on all three of our shaders. And for all three of our shaders, the first material X multiply here on a temperature, this goes into the emission. And our black body down here goes into the emission color. And let's do the same for all three shaders. So this is the final material done. And now let's take a look at the version that's compatible with Karma XPU. I brought in another material library. As you can see, the output is pretty much the same, but now we can change to Karma XPU in here and we still get a rendered image in the end. Let's take a look at what we changed in here. Jump into this material library, jump into this network. And as we know, the issue with Karma XPU is that we can just use one or two material X standard surfaces. So in this case, we're just using one material X standard surface. And instead of using those mix nodes after our shader to mix between different shaders, we're using them all in here and in here and in here to mix between different properties or different textures that we're piping into this shader. So for those three materials that I built, the only properties that I changed was the base color, the roughness, and the metalness. So these are those three inputs that are going in here. And for a color, I blended between two textures. This is our Entagma N, this is our UV grid, and also a simple solid color. This is this right here for our stand. And for roughness, these were all just single values, not textures. So in here, I'm blending between those values and between those values. And for metalness, it's the same story. I'm blending between those values. And then finally, we still have the same glow setup down here, which now goes just into the emission inputs of this single material X standard surface. So as you can see, this still works. But again, the more properties you change from material to material, and the more materials you use, the more complex this shader graph gets, and the more annoying it gets to build. Now finally, this is our UV workflow. And now as a final step, I want to quickly show you the workflow for using point colors and point attributes instead of UVs. And then we're going to finish up this episode. So this is our color setup getting rendered right here. And as you can see, and as I told you in the overview at the beginning, the main trade-offs for this setup in here is we get some blurry colors, we don't get those crisp lines as with UV attributes, and we have a bit of a harder time hiding this transition from a fluid to a main object, but we don't have those UV seam issues. So let's take a quick look at how we get there. Jumping back to our OBJ setup, this is a whole node tree that we need to build if we're going this route. As you can see right here, we don't create those mask attributes. What we do instead is we do a lot more here where we're transferring our main attributes to a fluid surface. And we're doing so much in fact that I put it into a subnet. Now, what does this subnetwork do? It basically does the same thing that our shader did in the last setup. So we have 3 sections up here. On the first section, we first of all do a vertex split from before, because this also helps in here a bit. And we're also promoting a name attribute from primitive to point, because in some cases, in fact for this attribute from map node that we're going to use shortly, this is also needed. And now what we're doing in these 3 blocks right here is writing our properties that we would change on a shader simply to point attributes. Starting first of all with a diffuse color. So first of all, work here on a preview surface and we're loading in a UV grid to this texture right here. Then we're doing this UV transform that we did in a shader as well, and use this to transform our Entagma N. And finally, to the rest, we're adding a solid color, the solid color that would be our stand, like this. Then you do the same thing for our roughnesses. In this case, we're not using textures, we're just using single values. I'm just using attribute create nodes for this. And again, with those, we're grabbing the name, we're giving it the right roughness name, and then we're adding in to this field right here the right value that we need for a setup, like this. And we're going to do the exact same thing for a metalness. So in the end, taking a look at the info panel, instead of having mask attributes, we have attributes for our diffuse color, our metalness, and our roughness that we can later use for shading. Then again, we're going to use a attribute transfer node to transfer those to our main fluid, and we're going to blur it right here. Then we're still going to merge our 2 streams together to create this nice normal transition between our main object and our fluid object, but we later have to split this again, so this is why I'm adding this group node right here, which groups everything on this geostream, and then down here I'm using the split node to split it into these 2 sections. Then we're going to use some attribute deletes to keep all the right attributes, first of all for a fluid, and then for a high poly object, and then we're going to import those as separate objects into a karma setup. Taking a look at our karma setup, we're first of all importing both of our objects. In this case, I did keep the name attribute on a high poly object, so this is separated into a core, a preview surface, and a stand, and we still have a fluid with this mesh 0 mesh inside. And then in our material library, now instead of having 1 material, we have 4 for 4 objects, 3 for a high poly object, 1 for a fluid. And in all of those high poly objects, we still have the same setup for our emission. And then we would shade this pretty much as we would shade every other object in Houdini. So in this case, for our preview surface, here we have a UV grid and nothing else. And then for a fluid, this looks a bit different. We still have the same emission setup as before, which goes into the emission inputs. But now we also have these different attributes that we created in our sub setup. So we have our color and we have our metalness and our roughness, and these go into the specific inputs of this material extended surface. And to make the transition between a fluid and a high poly object not quite as harsh, I did also use the total burn attribute down here along with a remap to drive the opacity of a fluid to make this transition from this area to this area a bit softer. But this is all what's to this workflow right here. If you don't want issues around UV seams, you're going to choose this workflow and live with sort of blurry colors or blurry details. If you can't live with blurry details, you're going to use the workflow that I showed you first and live with issues around the UV seams. But this is it for today. I hope you have fun rebuilding this. You're going to find all these different variations as separate scene files in the scene file download. And until next time, it's cheers and goodbye. If you like what we're doing, please consider becoming a patron of ours, not only for supporting Entagma, but for access to in-depth courses on topics such as KineFX, Vellum, Vex, Python, and so on and so forth. Also, let me say thank you so much to all our existing patrons. Without you, this channel would not be possible. Thank you.